Hello. Today I'll be talking about multiplying and dividing radical expressions. But first you need to know how to simplify something like this. So if you have the square root of 27, you know it's apparently not an even root. You can estimate, you know it's between the square root of 25 and the square root of 36, so it's got to be somewhere between 5 and 6. But there's another way you can write it that's exact but simplified. So we know square root of 27 is the same as square root of 9 times 3. Or we can take the square root of 9. The square root of 9 is 3. So you take that out, and you leave what you can't take the square root of in. So that would be a simplified form of the square root of 27. You do this with a lot of your problems. We have the square root of 98. Well, what perfect square will go into 98? So you can list out perfect squares. You know it's 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, ... Well, so we know 49 will go into 98. 49 times 2. Can't take the square root of 2, but you can take the square root of 49. Square root of 49 is 7, left with square root of 2 on the inside. You can do the same thing with letters, with exponents. We know if there's no number up here, that means a 2. And the best way to look at these is by converting it into a fraction. Because we know it's exponent over the root. So if we divide the exponent by the root, that'll tell us what we could take out and what we have to leave in. So say we have 7 over 2, that's 3, remainder 1. So we take 3 out, 3 x's come out, and we leave 1x in. So it's going to be x cubed comes out, and we have the square root of x, 1x on the inside. Same thing here. We have the cube root of x to the 10th, y to the 12th. So we have two fractions. For the x, that's 10 over 10 over 3. And this one gives us 12 over 3. So 10 over 3 becomes 3 remainder 1, just like the last one. So we take 3 out, we leave 1x in, and this is 4 remainder 0. So we take 4 out and we don't leave any. So this, in simplified form, would be x cubed, y to the 4th, and we leave in, make sure you don't forget to write that little cube root symbol. Little 3 goes in there. We don't leave any y's in, but we leave 1x in. So that would be it. Couple more examples. We have the cube root of 8. We automatically know the cube root of 8 is 2. Do the same thing here. 3 divided by 3 for our x. 3 divided by 3. That's easy. We take 1x out, we leave none in. 1 remainder 0. Take 1x out, leave 1 in. Y squared. Well, for the y, we have 2 divided by 3. That's all remainder. We can't take any out. So we have left inside the cube root of no x's and 2 y's, because this is 0 remainder 2. So y squared stays inside, because you can't take it out. 2 divided by 3 is a fraction. Last one. You have to look at each thing separately. So say we can break up negative 32. We're looking at a cube root. So perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, ... 8 goes into 32. And since it's a cube root, we could also take out the negative. So we have negative 8 times 4 is 32. Then we could set up fractions for the a and the b, and that'll give us our answer. We have 6 over 3 for the a, and 14 over 3 for the b. So we know we could take out the negative 8. The cube root of negative 8 is negative 2. 6 divided by 3 is 2, remainder 0. So we take two a's out. 14 divided by 3 is 4 with the remainder. So we can take out 4 b's, and we're going to have to leave 2 in, because 3 goes into 12, but not 14. Cube root of whatever we have left over. We did not take out the 4. We took out all the a's, but we left in 2 b's. Alright, next I'll be talking about multiplying two radicals. What you do need to know is they both have to have the same root, so we could write that. Must have same root, or index. Alright, so square root of 6 times square root of 3, multiply them like normal, keep them in the root. Square root of 6 times 3 is 18. And then you could break out the 18 into 9 times 3. So this is really square root of 9 times 3, where we know the square root of 9 is 3. So that can be taken out, and we're left with 3. Oh, I'm sorry, this is 9 times 2. We're left with 3 root 2, because we can take out the 9, but we cannot take out the 2. For this next one, our first step is to multiply the inside. So we're going to come out with the cube root of s squared times s to the 4th is s to the 6th. T to the 4th times t to the 6th. You just add the exponents is t to the 10th. Then we deal with it the same way we did before. For the s, we have 6 over 10. Oh, 6 over 3, I'm sorry. And for the t, we have 10 over 3. So, we could look at the quotient of these. 6 divided by 3 is 2, remainder 0. So we can take out 2, we leave none in. 10 divided by 3 is 3, remainder 1. So our answer equals, take two s's out, so s squared t cubed. And we have the cube root of whatever we did not take out. We took out all the s's, but we left one t inside. Continuing on, same thing here. We have a minus b to the 5th and a minus b to the 7th. We can combine those, so we have the cube root of a minus b to the 5 plus 7, 7, 8, 9, 10, 11, 12. And that will leave us with a minus b. 12 divided by 3 is 4, so a minus b to the 4th power. Same thing, 4th root of 28 cubed times 4th root of 4a squared. That's going to give us the 4th root of 20 times 4 is 80. A cubed times a squared is a to the 6th, or a to the 5th, because we're adding exponents. Equals, we need to look at 4th roots, or perfect 4th powers that go into 80. So 1 to the 4th power is 1. 2 to the 4th power is 16. 3 to the 4th power is 81. Dot, dot, dot. 16 will go into 80. So we could break out the 80 into 16 times 5. Well, we can take out the 16. The 4th root of 16 is 2. And then a to the 5th, that would give us 5 divided by 4, because it's exponent divided by root, which gives us 1 remainder 1. So we can take 1a out, and we have to leave 1a in the 4th root with the 5, since we didn't take out the 5. So 5a was inside. That would be that one. Now you can get some special cases. Here, we could multiply the insides, but another way of dealing with it, say if these were not the same, say this was the 4th root, we could rewrite it. This would be x to the 2/3 because it's exponent divided by the root times x to the 5/3. Now when we were multiplying terms with exponents, we add the exponents. 2/3 plus 5/3. And if you didn't have a common denominator, you would have to make one. That would be 2 plus 5 is 7/3. So you could either say 7/3, or you could say the cube root of x to the 7th, which could easily be simplified because exponent divided by root 7/3 is 2 remainder 1. So we could take 2 x's out and leave 1 in. So it might look like x squared times the cube root of x to the first power. Since that's how many we take out, that's how many we leave in. Alright, next we'll be dividing radical expressions. So say we have the cube root of 343 over 1,000. What you can do is just break it up into two roots. If they're perfect, you can take them right out. Cube root of 343 is 7 over cube root of 1,000 is 10. Easily done. For this one, we have to think, okay, we have exponents and roots because they're all letters. So for the a, the fraction would be 5/4. For the b, that would be 8/4. And for the c, we would have 10/4. So 5 divided by 4 is 1, remainder 1. 8 divided by 4 is 2, remainder 0. So we take 2 out, we leave none in. And 10 divided by 4 is 2, remainder 2. So our answer for this, whatever's on the top will stay on the top, and whatever's on the bottom will stay on the bottom. We take out 1a, 2 b's, over, we took out 2 c's. And we have left in the root, and keep it as a fourth root, 1a, no b's, and 2 c's. So we have 1a left over 2 c's. And the last one, since these are not the same root, we can't really combine them, but we can write them as fractional exponents. We have 4/3, so a to the 4/3 over a to the 1/4. Whenever you divide, you subtract. So really this is the same as a to the 4/3 minus 1/4. Need a common denominator. So we multiply this. We know 3 and 4 both go into 12, so we multiply this by 4 and this by 3. So we get a to the 16/12 minus 3/12, which would be a 16 minus 3 is 13/12. You can simplify this, but we can stop here. Alright, and last, I'll be talking about rationalizing the denominator. When you rationalize the denominator, you want to write it in two separate fractions. And we're trying to get rid of the radical in the denominator, so we don't want the radical. Now, to get rid of a square root, we would usually square it. But squaring it's the same as multiplying it by itself. So if we multiply this by square root of 7, if you do it to the bottom, you have to do it to the top. And it's just going to be the same as the bottom. We would get the square root of 6 times 7 is the square root of 42 over square root of 7 times 7 is the square root of 49. 42 you can't break up. So we have the square root of 42 over square root of 49 is 7. Number 2, we have the square root of 5 over the square root of 7x. If you're trying to get rid of the square root, you need 2 of them. So we have the square root of 7x on the bottom and the top. And we are multiplying. So that gives us 5 times 7x is square root of 35x over square root of 7x times itself. Whenever you multiply a root times itself, you always get what the inside is. Because that would give us 7 times 7 is 49. X times x is x squared. Well, the square root of 49 x squared is just 7x. And the last one, if you have a cube root, you need 3 of them total to get rid of it. So here we'd have to multiply by the cube root of x times the cube root of x on both the top and bottom. So we would end up with cube root of 4 times cube root of x times cube root of x is the cube root of 4x squared. Can't simplify that over cube root of x times itself. That's the same as the cube root of x cubed. It's going to all cancel out. Leave us with x. And that'll be it for today.